Hi, everybody. Um, I know you don't usually see me like this. I'm usually wearing my mask, but I want to give you some review of our first week and give some progress and just make sure that everybody's on task and caught up in the same place. The first and one of the most important things that I find that students seem to have trouble with is adding integers. I don't know why this is such a problem, but part of the reason I think is that as children in elementary school, they were taught to add with their fingers, and it's really difficult to add negative fingers. So, what I want to do is I'm going to go through and I want you to think about what is the rule for adding integers. Of course, you guys should be doing these on the side. If you don't have a piece of paper, get one now. And I want you to think of the rule. What is the rule for adding integers? I use a two-word rule, and it always works. It's ooh, oops. See if I got my pen going here. Why isn't my pen working? There we go. Who won? That's my rule. I simply look at the two numbers and I'm comparing -3 with +7. The positive is assumed. Even though you don't see it, it's still there. Now, when I ask who won, well, obviously the positives win. But the important thing is by how much did they win? And the +7 wins by 4. And that is a +4. Now, some of you learned the rules a different way. And as long as it's consistent, fast, and easy to use, I have no problem with that. But I find this one to be very intuitive. In this second problem, we have +2. Remember that it's not written on there, but it is there. There are 2 positives and 5 negatives. This time the negatives won by 3. That makes -3. It really is that easy. Now, the problem with negatives is that a lot of students learned that a negative times a negative is a positive. And that's true. But a negative plus a negative is always negative. Here's a reason why that happens. If you go out and spend $3 at the store and spend another $5 at another store, you spent $8. Debt accumulates. That is -8. Another way to think of this is that if you're doing the who won, think about it like this. If the negative score 1, then the negative score 2, then the negative score 3, and the positive score 4, who won? Well, clearly, this piece is a -6, isn't it? And we're still asking who won, but notice that the negatives joined up, and that gave us -2. Um, I want you to use the rule who won. And of course, the same goes for 2 positives. They've always added together to give you 11. They always will. Now, a very common mistake that I see students make is that they want to add on their fingers. And they go 8, 9, 10, 11. That is a terrible method. It will give you problems in the long run. What you want to do is what we call conjugation, which means that I need 2 more to make 10. So what I do is in my head, I split this 3 into 2 plus 1. And then the 8 plus 2 gives me the 10, and 1 more makes 11. Now, this seems like a harder method, but I want you to think about how much easier this method is when you want to add 97 plus 9. And think about how you would do this. Now, a lot of students are going to go 97, 98, 99, 100, 101, 102, 103, 104, 105, 106. But if you understand conjugation, you just think, oh, there's 3 that I need for this. And that leaves me with an extra 6. That's 106. What you'll find is that conjugation is much, much easier, even though it seems harder at the beginning. The next part, let's go to the next page. Oh, by the way, When you want to practice your addition of integers, a really good idea is to go to orbit integers and play your game. So we go to orbit integers. Let's do that real quick. And you just simply go to any Google. Here we go. Oops. I don't want that. I want orbit. Dang it. Sorry, it's going to take longer than I wanted. There we go. Go to orbit integers. And there you go. Very first one. And you play your game. You guys should be playing games until you get to maybe 20 additions in a minute. And I think I'm going to have to move this up just a little bit. Why don't you do them with me? Think about them, what the answer is aloud while I tap it on here. That's 4, -2. 1 plus 3 is 4. The negatives win by 5. The negatives win by 2. The positives win by 4. The negatives win by 4. That's +9. That's +6. That's -6. Looks like that 6th grader's kicking my butt. -7, 0, 1, 7, 10, -2, -6, 13, -5, -10, oh, darn, bad, my bad, 15, 11, 0, 1, -1, 13, -7, 4, -12. Okay, so let's take a look and see. I messed up one of them, so my percentage is going to be lower than 100. I only got 96%. Now it's going 33 per minute. If you're doing 20 per minute or better, you're probably okay. You'll need to get good at putting these things together, okay? Let's go back and look at the other part of week 1, which was subtracting integers. Do you remember the rule? If you watched the video, apparently some people didn't like it. I got some thumbs down. But subtraction, we don't do it. We don't do subtraction, not ever. We do addition. And what we do is we add the opposite. That's what we mean by subtraction. We always add the opposite. Now I'm going to put this, my pen in another color when I change this to addition. Actually, you know what? I think I'll leave it for now and then I'll change it in a minute. All right, this says -5 minus, and there really is a positive here. So what I'm going to do is I'm going to put the stuff that's invisible in blue. I know you usually use green, but there really is a +6 there, even though you don't see it. And there really is a +4 and a +2. This subtraction is called an operation or an operator. And this is a +8, and this is a +12. Now those are really there, even though we don't see them. Now what we're going to do is we're going to rewrite these subtractions as additions. And this says -5. I change the subtraction to the addition operator, and I'm going to add the opposite in every case. Now the first number doesn't change because the operation is happening on the second number. And we're operating on the second number, so we're subtracting +6. That's the same as adding -6. That's the same as adding +7. That's the same as adding -2. And that's the same, this bottom piece is the same as adding -12. We don't do subtraction. We add the opposite. Notice that I am now using adding the opposite, which is 1. And in this case, it's -11. In this case, the positives win by 4. In this case, the positives win by 2. And in this case, the negatives win by 4. You need to be able to subtract. You need to be able to add integers. I can't tell you how many students I've had, probably around 10,000. And out of all those students, the most common problem that causes people to fail is that they don't know their signed numbers. Now, the third thing that I want you to learn about, and hopefully you watched the J3 video that I created for IXL, and it's about solving equations. Now, a lot of people want to say, oh, I am just going to fill in the blank. And this almost caused me to drop out of high school and fail algebra, first of all, and I was going to drop out of high school. So not a good plan. Do not fill in the blank. You will be very tempted to do this because it just seems easier. 2 plus 2, of course, is 4. And thinking of solving equations this way will lead you to the same problem that I had. Now, of course, you're probably going to have to make your own mistake, and eventually you'll understand why I'm telling you this. But you are supposed to do the opposite to both sides in order to undo adding 2. Undoing adding 2 is subtracting 2, but we don't really do subtraction. We add a negative 2, don't we? 2 plus negative 2 is 0. And the x is now by itself. Looks like I'm running out of space on the bottom here. And that 4 plus negative 2 is 2. This is how you solve equations. That's a one-step equation. We do the opposite. To both sides. Now there's one more piece to this, and it's in reverse order, but that is important when you do two-step equations. For today, our assignment is going to be to look at special multiplications. And there's a reason I want to teach you this. It's something new. A lot of people don't know it. And it will be something that you can teach someone else this weekend. And that is your assignment. You must learn this well enough to teach someone else. And it's a really important role change for you. So I want you to really focus and learn how to teach this. Today, I'm going to give you a breakout room. You're going to try to teach your partner how to do it. You're going to get some examples. First of all, before we get started though, let's multiply this normally. And everybody should pause the video at this point and multiply these out like you normally would. So do that. Do not wait for me. Go ahead. Seriously, pause the video and get some paper and do the problems. Multiply these out. Now, I'm going to tell you the answers, and I'm literally doing these in my head, and then I'm going to tell you what I'm doing. This first one is 621. The second one is 2025. This third one is 5616, 5616. This one is 3024, and this one is 4209. Now you can check your answers, and if you multiplied them correctly, you should have gotten those answers. Now what I'm doing, this is a special case. The 2s are the same, they're the tens digits. The 4s are the same, it's the tens digits. The 7s are the same. Notice the tens digits must be the same. There's a second thing that has to happen. The 7 and the 3 adds up to 10. We call those conjugates. 5 and 5, 8 and 2, 6 and 4, 1 and 9, all add up to 10. Now the rule is that you add 1 right there to that tens digit. 2 plus 1 is 3. Multiply it by 2 and you get 6. 3 times 7 is 21. It is that easy. Now remember, this only works for these special cases, but there are a lot of them. Now 4 plus 1 is 5. 5 times 4 is 20. 5 times 5 is 25. The reason I'm adding 1 is because there's some extra multiplications and additions going on that we're not seeing. Normally, we would have to multiply the 2 times the 8, then get the 16, and then we'd have to multiply the 2 times the 70. But we'd also have to multiply the 7 times the 80. What happens is when you add those together, it is the same as putting this little 1 right there. Now, later on in the course, we're going to learn a thing called FOIL, binomial multiplication, and so on. And I'll be able to show you where all these numbers come from and why they work. 8 times 7 is 56, and 2 times 8 is 16. 5 times 6 is 30. 6 times 4 is 24. 6 times 7 is 42. And here's the problem. 1 times 9 is 9, but you have to have 2 digits. So you have to write the 0, 9, just like you do for the date, or used to do for the date. Well, there you have it. That's special multiplication. You can watch the long version if you didn't get it from here. Otherwise, I'm going to have you teach each other in your breakout rooms. You're going to put on a paper or write in the side in the chat an explanation. We're going to see if you can share the whiteboard. We'll try it as an experiment tomorrow and see if you're able to share your whiteboard within your breakout room with your partner. So it's going to be a bit of an experiment, but I'll see you there. Bye-bye.